Very good. So, and I was very surprised to see when I wanted to buy a laser pointer ads on websites, one of which said it was the world's most powerful laser pointer.
Ooh,
and so I read why. The reason is that any laser device 5 milliwatts or higher becomes a different class of laser and is not allowed as a laser pointer. So the world's most powerful laser pointer is hand-trimmed in the factory to be exactly 4.99 milliwatts. Because if it was 5, it couldn't be a laser pointer. So, yeah.
What will it be?
It would be a laser. It wouldn't be a laser pointer. It would be a class 1 laser. So, anyhow, this is the ad on the website.
So what can you do with a 4.99 laser? What can you do?
Somebody shine those dots again on the screen.
One is brighter than the other.
Yeah, one is brighter than the other. Whoever has the bright one, is it written on the side of your laser what the power is?
Who is it?
Look around at the fine print. I think she can read. Yeah, so it's labeled as less than 5. As opposed to 4.99, that may only be 4.8. Okay.
So how do you know yours?
Because it came with a certificate that showed the person who tuned it, and then at the time when it was shipped, it was 4.99.
How much was it?
So what can you do with a more
I don't know. It's like
kill a person.
No, they don't hurt when they get consumed. Okay. Now, interestingly enough, green seems brighter. That's because green is in the middle of our optical range. And so it seems to us when the same power in milliwatts of red and green are displayed on a surface, that the green seems brightest. If you head towards the blue, which is again at one end of our sensitivity, it seems less bright. So in fact, green at 4.99 also seems brighter. So move up a little bit. I can't see all the words. Okay, a commercial green laser pointer, as shown in the figure below, supplies an output power of 5 milliwatts. So, yeah, you're right. 4.99. Okay. At a wavelength of 532 nanometers, the light is contained in a spot of radius 1 millimeter. Okay. Before I read any of the A, B, C, D questions, what information have I given you?
Power.
I've given you the power in watts, and what else have I given you?
Wavelength and radius.
I've given you the wavelength and the radius. What would you do with that radius?
Intensity.
Yes. You'd use it to find the area in which the laser spot was contained. So in fact, by giving you the power and the area, I have given you what?
Intensity.
5 milliwatts divided by, did it say radius of 1 millimeter? Radius. And what's the area of the system? Pi r squared. And so the intensity of this laser is?
Yeah. 1892.
Oh, you flew well with that way. Yeah.
That's more intense than sun. But it's only a millimeter spot. Okay, now, what else do they want to know, now that we know that information? Oh, what's the frequency? How will we find the frequency?
Easy over the head.
500 and what?
32. Minus.
So, yes, and nano is minus 9.
Five point 6 times 10 to the 14.
Really?
Yeah.
Okay, 10 to 14 hertz. What else do they want to know? Oh, what's the intensity? We already got that. Now what's U?
Yeah, energy density.
Yeah, so how would I get the energy density?
Divide I by K.
Equals what?
5.3 times 10 minus 6.
Yeah.
So the laser has a microjoule per cubic meter. What is the average electric field strength of these EM waves? How would I get that?
Well, U is equal to 1 half epsilon 0 times U squared.
Not 1/2.
Oh, it's not magnetic.
You could say 1/2 epsilon 0 E squared plus 1/2 C squared over mu naught for the full. Or you could say twice either term. So that would be the correct expression for U. And
But then you have to get average, so then you have to divide it by a radical 2 at the end.
no,
That already gives you average.
I'm already in the process of taking the square root. Taking the square root of an average quantity, so I'm going to get what for E?
Yeah, 3.84 something. Is the square root defined? No, it's U. It's U.
It gives you something that's proportional to the amplitude. Amplitude is electric field. So I first divided by C to get U, then divided by epsilon naught, then square root is giving you the amplitude. Is the amplitude. So what do we get for the electric field?
774.
How much?
774.
And how would we get the B?
Using the B squared over mu naught.
Yes, you could use B squared over mu naught,
Or it's,
or
E divided by 6.
it's E over C. And the reason is, C is a combination of mu 0 and epsilon 0, correct? C is equal to 1 over square root of mu 0 epsilon 0. Okay, so what do I get for the magnetic field? 2.6. Tesla. Named after him after he died. He had a rough life. Yeah, partly because of Edison. He and Edison had a big fight. Did I tell you about the War of the Currents? Well, Edison made the first electric plant. it could send electricity, DC, an absolute maximum of 2 miles. Tesla said I can send it as far as you want if I use AC. And he was right. But everybody said AC is ridiculous. AC could never work. But Tesla had an idea, and after working for Edison and getting into a fight, he broke off. He dug ditches for a while in order to save up money. Then he made an AC motor, he made a transformer, and an AC generator. Demonstrated that they would all work. And so Edison then decided he had to discredit Tesla. And so he went around saying that the problem with AC is that it's dangerous. Well, so is DC. It's just a matter of the high voltages. But then in order to prove his point, Edison started killing things. So there was an elephant that had killed its trainer in a circus. So he publicly executed the elephant at Coney Island using AC power. And Edison invented the electric chair to run on AC power to show that, oh, you better not use AC, it's dangerous. See, we kill criminals with it. The only problem is he didn't know quite how much to use to kill a criminal, and it wasn't quite enough, and it took quite a while to kill the first person in the first, it was not pretty. But yeah, they spent their lives in a war over these things. And at one point, this is a mystery to this day, at one point the New York Times announced that Edison and Tesla would share the Nobel Prize in Physics. 2 weeks later, it was given to somebody else named Bragg, who won it for Bragg scattering, and it's never been explained what happened, but the theory is that either one or both of them refused to accept the Nobel Prize as long as the other name was there. and that's what happened. But it's not known what really happened. So, in the end, Tesla went a little and he was telling people that he knew how to make death rays and other things like that, and
You didn't know how to make that rain.
Eat it,
I have a schematic in my room.
Oh, you can get his schematics off the web. They don't seem to do much. Yeah, but in the end, it was recognized that this guy who was discredited, penniless, etc., when he died, that he really was a brilliant guy, and so in the 60s, they renamed the magnetic field unit to be a Tesla.
What was it before? Was it called Edison?
It didn't have a name before. Just like momentum isn't a named unit.
Should be named Temex.
Just like momentum is not a named unit.
How come it's not named Temex?
The momentum's been around for hundreds of years before any, at least before this Temex. Yeah. No. Okay. So, how long?
Give me